transit method. Astronomers have confirmed many planetary systems with more than one planet in the habitable zone of their stars. This particular system has 3 and is a promising early target for the James Webb Space Telescope. The whole system is tiny, revolving around a very cool star named TRAPPIST-1, which is not much bigger than our own planet Jupiter. All 7 planets orbit within a zone smaller than the orbit of Mercury, our innermost planet. Using the Webb to compare their atmospheres may give scientists a roadmap to detecting life in many other systems. These 7 planets affect one another's orbits. In a few such systems, the planets' gravitational interactions have pulled them into a stable, resonant ballet. They come closest together at regular repeated intervals. We're currently exchanging their momentum to keep the timing constant, like a precisely built clock. Truly, music of the spheres. This exchange of energy can warm these little worlds, encouraging chemical reactions as tides incite their fluids to mix. It is possible that life could arise on even smaller objects. In 2021, astronomers using the ALMA Array Radio Telescope detected a disk of material swirling around PDS 70c, a massive exoplanet 400 light-years away. It was the first observation of moons caught in the act of forming around a planet. Once built, such moons can hold deep subsurface oceans beneath protective shells of ice. Exactly this is happening within our own solar system. Jupiter's 4 largest moons, the ones discovered by Galileo in 1610, flex and tremble due to tidal gravity. Ganymede, Callisto, and especially Europa are nearly certain to host subsurface oceans. Saturn's huge moon, Titan, and tiny Enceladus each contain a liquid sea beneath their crusts. In February 2005, the Cassini mission first began picking up evidence of salty water spewing from large cracks in the icy surface of Enceladus. These could be snow globe worlds. Deep within the oceans of Earth, oases of life have been discovered. These lush ecosystems don't require sunlight. They draw energy and nutrients from hot water gushing through fissures in the seabed, driven by our planet's molten interior. A similar alien undersea realm on a nearby moon or a distant exoplanet may await discovery. It is difficult to imagine how such a detection could be made without sending a probe. There are plans to try just that in our own solar system. Stars, however, are almost unimaginably far apart. It's not yet practical to send spacecraft to even the very nearest ones. Fortunately, astronomers have come up with ways to gather clues to life from afar. If the orbit of an exoplanet crosses the face of its star, starlight filtering through that planet's atmosphere can disclose its makeup, element by element. In 2001, the Hubble Space Telescope identified hydrogen, oxygen, carbon monoxide, and sodium in the high, hot clouds of a giant world named Osiris. Later analyses found water vapor, methane, and carbon dioxide. Osiris is likely too hot, too dry, and too close to its star to host life. But this detection sparked the quest for biomarkers, molecules in the atmospheres of exoplanets, which could be the exhalations of life. Operating at longer wavelengths than the Hubble, the new James Webb and Nancy Grace Roman space telescopes can determine chemical composition more clearly. The shifting balance between methane, carbon dioxide, and oxygen can point to the developmental stage of a planet's biology. Planets are also brighter in the infrared than in visible light, while stars are dimmer. Infrared detectors can see through clouds of interstellar dust and penetrate the local star soot emitted by the parent suns of exoplanets. By deploying a star shade, future space telescopes could simulate an eclipse of a parent star, blocking enough starlight to determine an exoplanet's overall color, and perhaps taking direct photos of its surface and atmosphere. What astronomers are looking for are signatures of change. On our amazing planet, primitive plant life dramatically altered the atmosphere, consuming carbon dioxide and releasing oxygen, poisoning and